NASA's exploration of Mars has long captivated the imagination of humanity, achieving extraordinary milestones that have significantly advanced our understanding of the red planet. One of the most groundbreaking accomplishments in this endeavor was the landing of the Perseverance rover in February 2021. This state-of-the-art robotic explorer has provided some of the most breathtaking visuals of Mars ever captured, high-definition 4K images that vividly reveal the planet's ancient, rugged terrain. Perseverance builds upon the legacy of earlier missions, particularly the Curiosity rover, by continuing to push the boundaries of planetary science. Both rovers have played pivotal roles in revolutionizing our knowledge about Mars, particularly regarding its geological history, climate evolution, and potential for harboring life. Perseverance landed in Jezero Crater, a site carefully selected by scientists due to strong evidence that it was once a vast lake over 3.2 billion years ago. The location is considered a prime candidate for finding ancient microbial life. Armed with advanced imaging systems and a sophisticated suite of scientific instruments, the rover has been gathering invaluable data. These images and readings do more than just provide visual grandeur. They offer vital clues to Mars' past, helping researchers piece together the planet's environmental conditions and assess its suitability for future human exploration. NASA's immense investment in Mars exploration, amounting to billions of dollars, is driven by the desire to answer one of the most profound questions in science: are we alone in the universe? This mission is a continuation of NASA's long-standing robotic presence on Mars, which began gaining traction with the launch of the twin rovers Spirit and Opportunity in 2003. These two rovers were initially expected to operate for only 90 Martian days, but Opportunity surpassed expectations by continuing its mission for nearly 15 years. Both rovers played essential roles in transforming our understanding of Mars by uncovering evidence that liquid water once flowed on its surface. Their discoveries included sedimentary rocks and the iconic hematite spheres known as blueberries, which typically form in water-rich environments. Spirit, despite becoming immobilized in soft Martian soil, contributed significantly by finding signs of past hydrothermal activity, regions where hot water once flowed below the surface. These early missions laid the groundwork for more advanced explorations by proving that Mars once had the necessary conditions to support water, a key ingredient for life. In 2012, the Curiosity rover made a historic landing in Jezero Crater as part of NASA's Mars Science Laboratory mission. This crater was chosen because of its rich geological landscape and signs of past water activity. At the heart of Jezero Crater stands Mount Sharp, a towering peak that rises 5.5 kilometers above the crater floor. Its layered rock formations serve as a historical archive of Mars' environmental evolution. Curiosity was designed to determine whether Mars ever had the chemical ingredients necessary to support microbial life. It was equipped with a diverse array of instruments capable of analyzing the composition of rocks, soil, and atmosphere. Among its most advanced tools was the ChemistryCam, a laser-based system that vaporized rock samples to study the resulting plasma and identify their elemental makeup. This method provided critical insights into Mars' volcanic past, sedimentary history, and atmospheric interactions. Curiosity also investigated the Martian atmosphere to better understand the transition from a warm, wet planet to the cold, barren world it is today. Its radiation sensors collected vital data on cosmic rays and solar radiation, information that is essential for planning long-term human missions. One of Curiosity's most groundbreaking discoveries came in 2013 when it identified an ancient streambed within Jezero Crater, confirming that liquid water had once flowed there. Further detection of clay minerals lent strong support to the theory that Mars once had a hospitable environment. Additionally, fluctuations in methane levels, another of Curiosity's key findings, sparked speculation about possible biological or geological activity still occurring beneath the Martian surface. While Curiosity revolutionized our understanding of Mars, Perseverance has taken exploration to an entirely new level. Launched in 2020, Perseverance was designed not only to build upon the discoveries of its predecessor, but also to pursue more direct evidence of past life. One of its central missions is to collect and cache rock and soil samples for future return to Earth through an ambitious joint campaign with the European Space Agency. This sample return effort will enable scientists to conduct high-precision analyses in Earth-based laboratories, offering far greater accuracy than any instruments currently aboard a rover. In March 2021, Perseverance made its first test drive, marking the beginning of an extraordinary mission. Since then, it has uncovered many intriguing features such as unusual rock formations, nicknamed leopard spots, that may offer new insights into Mars' ancient climate and hydrology. The mission has inspired global interest and engagement. Initiatives like NASA's Send Your Name to Mars campaign allowed more than 10 million people to have their names etched onto a microchip aboard the rover, symbolizing humanity's shared passion for space exploration. Perseverance also paid tribute to healthcare workers during the COVID-19 pandemic by including a commemorative plate on the rover. A coded message embedded in its parachute, "Dare Mighty Things," a motto derived from President Theodore Roosevelt, underscored NASA's commitment to innovation and courage in exploration. Perseverance has returned some of the most detailed and iconic visuals ever captured on Mars. The famous Octavia E. Butler landing photo froze the dramatic moment the rover touched down, with smoke plumes visible from the descent stage. Other images, such as the panoramic view from Sol 14, showcased the planet's expansive and rugged landscape. The rear hazard avoidance camera not only aids in navigation but also offers striking views of the terrain. One particularly memorable image from Sol 213 captured the discarded parachute and backshell lying atop a distant ridge, serving as a powerful reminder of the mission's dramatic arrival. A groundbreaking element of the Perseverance mission is the inclusion of the Ingenuity helicopter. In April 2021, Ingenuity made history by achieving the first powered, controlled flight on another planet. The flight took place at a site dubbed Wright Brothers Field and demonstrated that aerial exploration is possible even in Mars' thin atmosphere. Though originally scheduled for just 5 test flights, Ingenuity far exceeded expectations by completing dozens of missions. It has helped scout terrain, chart optimal routes for Perseverance, and even captured unique aerial footage and audio recordings of the Martian environment. One of its standout moments came during its 11th flight in August 2021, when it photographed the Perseverance rover from the air, offering a remarkable and rarely seen view of the mission in action. Images taken by both Perseverance and Ingenuity have greatly enhanced our ability to map the Martian landscape and identify promising areas for scientific study. This synergy between the two machines underscores a new era of cooperative robotic exploration that could pave the way for future human missions. Perseverance's technological contributions go beyond imaging and mobility. One of its innovative instruments, the Mars Oxygen In Situ Resource Utilization Experiment, MOXIE, successfully converted carbon dioxide from Mars' atmosphere into oxygen. Though still in its experimental phase, this achievement represents a critical step toward making human missions to Mars more sustainable. Producing oxygen on site could drastically reduce the amount of supplies future astronauts would need to bring from Earth, lowering mission costs and simplifying logistics. Equally important is the way NASA has engaged the public through this mission. The inclusion of microphones aboard Perseverance has provided the first audio recordings from another planet, offering an entirely new sensory dimension to space exploration. The rich visuals, from 360-degree panoramas to microscopic images of rock textures, make Mars feel more accessible and real than ever before. NASA's approach to cultural symbolism and public participation has helped ensure that this mission resonates with people across the globe. Perseverance stands as a beacon of what robotic and human collaboration in space exploration can achieve. Its success is the culmination of decades of scientific innovation and engineering excellence. From the early triumphs of Spirit and Opportunity to the game-changing discoveries of Curiosity, and now the ambitious objectives of Perseverance, NASA's Mars missions have not only rewritten the story of a distant planet but also deepened our understanding of life's possibilities beyond Earth. As Perseverance and Ingenuity continue their mission on Mars, they are not just uncovering rocks and soil, they are laying the groundwork for humanity's future among the stars. The Perseverance mission is more than a scientific journey. It's a reflection of human ambition and our relentless pursuit of knowledge. The rover represents a turning point in planetary exploration where science, engineering, and public imagination converge. As it continues to traverse the Martian surface, Perseverance methodically studies sedimentary layers that may preserve biosignatures, chemical or structural traces of ancient life. These geological records could help scientists determine whether life ever evolved on Mars and, if so, under what conditions it might have thrived. Such insights not only reshape our understanding of the Red Planet but also have profound implications for understanding life's origins in the broader universe. Perseverance's sample caching mission is especially groundbreaking. It is the first time in history that a rover has been tasked with collecting rock and soil samples for potential return to Earth. This ambitious plan involves sealing selected samples into tubes and depositing them in strategic locations for retrieval by a future mission. NASA, in partnership with the European Space Agency, aims to launch the Mars Sample Return mission within the next decade. If successful, it would mark the first time material from another planet is brought back to Earth, an achievement that could unlock answers to questions we have pondered for generations. Equipped with an advanced instrument suite including PIXL, Planetary Instrument for X-ray Lithochemistry, and Sherlock, scanning habitable environments with Raman and luminescence for organics and chemicals, Perseverance can examine rocks at microscales, searching for organic compounds and potential fossilized remains of microbial life. These tools allow scientists to pinpoint chemical patterns associated with biological activity, helping them determine which areas may hold the most scientific value for sampling. Additionally, Perseverance's environmental sensors monitor Martian weather and dust levels, providing data crucial for future human settlement planning. Ingenuity, meanwhile, has proven that aerial exploration is not only possible but also immensely useful. By flying ahead of the rover, it scouts paths, identifies hazards, and offers perspectives no land-based rover could achieve. Its longevity and performance have made it a cornerstone in the discussion of future drone-based missions on other planets and moons. In essence, NASA's Mars exploration represents more than technological prowess, it reflects humanity's deep-rooted desire to explore the unknown. Each mission builds upon the legacy of the last, guiding us closer to the ultimate goal, setting foot on Mars. The discoveries made today are the stepping stones for tomorrow's astronauts, making Mars not just a scientific target, but a future destination.